has divided the thoughts that we have into relations of ideas and matters of fact. And he said, well, maybe the rationalists are right about relations of ideas. We do come to know these things just by reflecting on our own ideas. But when it comes to matters of fact, well, we face this problem. How do we know about these matters of fact? How do you know that someone's in the bathroom right now? How do you know that dinosaurs existed? How did you know that Pluto exists? And Hume's answer is, well, how do we know dinosaurs existed? Well, we dug up some fossils and we figured, there must have been some animals that were alive at one time that caused these fossils, these bones, to get buried and turn into fossilized rocks so that we're discovering them now. How do we know that Pluto exists? Well, we look up through telescopes into the sky and we see some interesting patterns of light reflected back through the telescope, and we assume, there must be a big chunk of rock and ice out there that is causing photons to bounce off of it and travel into the telescope and cause us to see this pattern of light. So in other words, the big thing that we're using to find out about matters of fact is this idea of cause and effect. We posit that there are certain things that cause certain effects to occur. Okay, so that's the first stage in Hume's answer. How do we know about matters of fact? Well, because we attribute causes to effects. And so now the question is, okay, so how do we know about cause and effect? How do we know that one thing is the cause of another? How do we know that something is the effect of a particular cause? And Hume's answer is a little disconcerting. He says, look, we do not have any good evidence or reason to think that one thing should cause another thing. After all, he says, look, if you saw water for the very first time, and it's kind of hard to get yourself in that mental space because we're all pretty darn familiar with water, but if you could imagine if you saw water for the first time, he'd say, look, there's no way you could possibly know that it would suffocate you if you tried to breathe under it. For all you know, looking at it at the first time, you'd say, oh, cool. It's kind of like thick, wet air. It would be awesome to go underneath there and walk around and breathe. You wouldn't know that it would suffocate you. In the same way, you could imagine, okay, so what if you took some steel wool, it's this these kind of fine filaments of steel they use for scrubbing pans in the kitchen. What if you took that and took a 9-volt battery and touched them together? Now, if you're like me and you've never seen anyone do this, you might think well, I don't know. I guess I could guess about it. Maybe it sends some electrical currents through the steel wool. I'm not really sure, but you probably can't know just by looking at the steel wool and looking at the battery what it will cause. What you're going to have to do is get some experience. So let's get some experience with it. Take some steel wool and a 9-volt battery and see what happens when you touch them together. So we've got the steel wool there in the background. We've got the 9-volt battery. Touch it to the steel wool. Holy shit. First time I saw this, I was like, I was not expecting that. It lights on freaking fire. So Hume would say there's no way you could know just by looking at the steel wool and looking at the battery that when you touch those two things together, the steel wool would go up in flame like it's doing right now. Now, you might say, oh, okay, but I know some other things just by looking at that steel wool. I know, for instance, what will happen to it when you light it on fire like that. So you might ask, well, what happens when you light steel wool on fire like this? Is it going to get heavier or lighter or stay the same weight? And you might think, oh, yeah, I'm familiar with this stuff. I've burnt plenty of stuff before. When you burn stuff, it always gets lighter. So let's see what happens. When you burn steel wool, does that cause it to stay the same weight or get heavier or lighter. So there's some steel wool again. Turns out you can light it on fire just by lighting a match. You don't need the 9-volt battery. So we're lighting it on fire. But now let's see what happens to the weight of that steel wool when you light it on fire. So we'll put it on a scale, put the same amount of steel wool on either side of a balance scale, and light the one side. And as you can see, it gets heavier, which might be kind of surprising to you if you've never lit steel wool on fire, because after all, when you burn wood certainly gets lighter when you burn it. But it turns out that when you burn steel wool, part of what happens is that steel, the iron in the steel takes oxygen from the air, and that oxygen binds to the iron, and so it actually becomes heavier. So it turns out that burning steel wool causes it to become heavier. But Hume would point out, look, there is no way you can know just by looking at that steel wool or just by reflecting on your idea of steel wool that that's the cause that lighting it on fire would have, that's the effect that would have. No, you have to go out there and experience the thing. So how do we know? How does experience tell us which things cause which effects? Well, Hume says again, we don't really have any good evidence for thinking that one thing is going to cause another thing. The best we can go for is just the fact that certain effects are, as he says, constantly conjoined with certain causes. And, we don't really, there's not like we can see something to be a cause or to be effect. All we see is that, first one thing happens, then another thing happens. And it seems like, almost every time that first thing happens, the second thing happens. And so that's the only reason that we take there to be some causal connection between those things. Every time we light up the steel wool on fire, it becomes heavier. So we assume, I guess lighting steel wool on fire causes it to become heavier. Just like when you hit one pool ball or one billiard ball with another billiard ball, that white ball, when it rams into the red ball, usually causes the red one to move. The only reason why you think that, knocking one ball into another ball causes it to move is because, every time in the past when that white ball has moved next to the red ball has moved as well. So what Hume has come up with here is a new way of reasoning, and it's a way that we can use these empiricist insights of himself and Locke and reason about different experiences that we have to come to conclusions about how things are. So he says, look, the best we can do when we're trying to figure out the way that matters of fact work out is to just look at how things have been going in the past and assume that things will turn out that way in the future. And this kind of reasoning is called induction. So we can reason by saying, look, I'm going to take the premises that bread nourished me last month, bread nourished me yesterday, it nourished me this morning, and so I'm going to come to the conclusion that bread will nourish me tonight. Now I know something. I know that bread causes me to be nourished, because after all, every time I've eaten bread in the past, it has nourished me. You can do the same thing with lots of other matters of fact. If you want to know whether the sun will rise and set tomorrow, you can reason, look, the sun rose and set last Thursday, it did it again on Tuesday, it did it yesterday. So it seems as though the sun is going to rise and set tomorrow. Now, you can ask a question about this sort of argument. Is this a valid argument? So remember, a valid argument is one in which if all the premises are true, the conclusion has to be true. The other way of putting that is to say, look, there's no way that all the premises could be true, and yet the conclusion could be false. And notice, inductive arguments like this, they ain't valid. All those premises could be true. It could be true that the sun has risen every single day before now, and yet today, there's just a freak nuclear explosion in the center of the sun, which causes it to just expand a million times its size and snuff out light on Earth. And, there's no more rising and setting. That's just how it is. There's no contradiction in assuming that, maybe today won't turn out the way things have every single day for the past couple million years or so. So inductive arguments do seem to be a way that we get knowledge, but they don't seem to be valid. Now you might say, well, so what if we try and patch this up and we put in another kind of premise in there? You could say, well, look, let's just take it as a premise that the sun will behave in the future as it has in the past. That's our first premise. And then our second premise is just, well, look, the sun always has risen and set in the past. Now we've got a valid argument. If those two premises are true, then it has to be true that the sun will rise and set tomorrow. But even if we take this as a valid argument, you can still ask, well, is it sound? Are all of the premises true? And you can ask, okay, so well, is it really true that the sun will behave in the future as it has in the past? Well, we could assume that that's true, but Hume points out, look, we just don't have any really good evidence or any really good reason to think that things will continue to happen in the future the way they always have in the past. Now, he notes, we usually assume that that's going to be true, and assuming that the future is going to behave like the past is what seems to allow us to come to conclusions about matters of fact, and it works pretty well so far as it goes. But when you come right down to it, we just don't have any really good evidence or reason to think that the future will behave as it will in the past. So, yeah, we can use experience to come to conclusions about matters of fact. We can reason, okay, burning steel was followed by this formation of iron oxide and the steel wool becoming heavier in the past. It's done that every single time in the past. And we can make the assumption, well, gosh, I mean, sure, I'm going to assume that, when I burn steel wool again today, the same thing's going to happen. And that will allow us to come to the conclusion that, oh yeah, so burning steel always causes the formation of iron oxide, and that causes the steel to get heavier. And so I can come up with this conclusion about a matter of fact that burning steel wool makes it heavier. But ultimately, Hume says, look, we cannot be fully certain about that knowledge because there's always the possibility that things in the future are going to be radically different than they are in the past. It certainly seems to us as though they're going to continue to be the same. We certainly seem to assume when we're going about our daily lives, and even when we're doing science, we tend to assume that when we run experiments in the future, they're going to turn out the way they have in the past. But Hume says, look, we don't have any good evidence or reason to think that that's the case. It's just a custom or a habit on our part, just an assumption. So Hume gives us a theory of how we can use experience to get knowledge about matters of fact, but it comes with kind of a high cost. Descartes was looking for absolutely certain knowledge that he couldn't possibly doubt. Hume saying, well, look, here's some knowledge you can have, some beliefs that are probably true, but there's always going to be the possibility that you're wrong about your beliefs, because there's always going to be this possibility lurking out there that our assumption that the future is going to behave like the past isn't going to turn out this time around.